Hey, welcome back from winter break. Glad to see you back in class. Anyway, today we're not doing a full-blown video. I'm just going over two problems from each lesson 6.6, 6.2, and 6.3. So that way if you didn't understand what we talked about in class, you can kind of rewatch these a couple times until you do understand. But anyway, it's just two problems from each lesson. It's not the entire lesson. And if you just want to see 6.2, then fast forward to that. Just want to see 6.3, fast forward to that. Okay, so this comes from lesson 6.6. Graph the system of linear inequalities. And then give two ordered pairs that are solutions and two that are not solutions. So we have three steps that we always follow on these. I'm trying to find a good color to write in. Let's do this. Step 1 is we solve the two linear inequalities for y. Step 2 is we graph both of those inequalities. Okay, and let's just leave it at 2 steps for right now. Step 3 would be to check it, but I'm assuming that you know how to do that. We're not going to practice that right now. So, step 1, solve for y. Solve for y means that y is on one side of the inequality all by itself. So in this top one, y is all by itself on the left side, no problem. On the bottom one, y has a bunch of stuff over here with it, so we need to solve this for y. First thing we need to do is we need to move this 3x over to the other side, and we do that with either addition or subtraction. That's how we move things from the left to the right. So it's a positive 3x. We move it by subtracting 3x on both sides. Okay, and then we get 6y is less than or equal to 12 minus 3x. And now we need to split up the 6 and the y. To split terms apart, okay, not just to move them, but to split them apart, we use multiplication and division. Right now the 6 and the y are being multiplied, so we split them apart by dividing. We got to split it, we got to divide on all of them. Okay, so those 6's cancel out, and we get y is less than or equal to 12 divided by 6 is 2. And then negative 3 over 6, we can reduce that fraction. It's negative 1/2 x. Okay, so there's the next equation. So now let's go ahead and graph them, and let me kind of erase so we can see what we're working with. Okay, so let's graph this top one. We'll graph it in pink. We got to make 2 dots. It's just like graphing lines. The first thing we look at is the y-intercept. The y-intercept is the number that is not attached to a letter, so negative 7. And we put a dot at negative 7 on the y-axis. And then we have to look at our slope to get the second dot. Okay, slope is whatever number is in front of x. There is no number in front of x, so we assume that it's 1, because 1 times x is the same as x. So our slope is 1. That's the rise over the run. Okay, we need a number on the bottom, whole number. The number on the bottom is 1. Okay, so then we go up 1 and to the right 1, and we put a new dot. Okay, we have to decide if we're going to connect these with a solid or dotted line. When it's just an inequality sign and there's no or equal to part at the bottom, it's a dotted line. So then we go ahead and make a little dotted line. All right, and now we need to shade it. Y is greater than the rest of the inequality. So since y is greater than, that's bigger than. Bigger means we shade up. So then we color in everything that's above that line we just made. Good, we're done with that one. Now let's do the second line. Okay, this one that we solved for y here. Now don't get tricked. The y-intercept is the number that doesn't have the letter next to it, so it's the 2. Okay, so our y-intercept is 2. We put a dot at 2. Now we need to look at the slope. It's negative 1/2. Okay, the slope is the number in front of x. So we drop down 1, and we go to the right 2, and we put another dot. We're going to connect these with a solid line because of the or equal to line underneath our inequality. So we connect those with a solid line. Okay, and now we need to decide whether to shade up or down. Well, in this case, y is less than everything else. It's smaller than, so smaller than means we shade down. And then we look at the area where the two shades, the red and the green shading, overlap. And that is right in here where we've got the red and the green shading overlapping. So all of the points that are inside this overlapping triangle, this orange triangle that I've just drawn, those are all solutions. And everything that's outside of that triangle where the shading does not overlap, those are not solutions. Here's another problem. Again, step one, we want to make sure that both of those equations are solved for y. Okay, and then step two, wow, okay, my pen's not working, hang on. Okay, step two will be to graph. Okay, so on the top one, y is already by itself, it's already solved for y. On the bottom equation, y is not by itself, we need to get y by itself. So we subtract 8x from both sides. And then we're left with 4y is less than or equal to 12 minus 8x. Now we want to split apart the 4 and the y, so they're being multiplied now. We divide. So divide everything by 4. And then we get y is less than or equal to 12 divided by 4 is 3. And negative 8 divided by 4 is negative 2, and we've still got the x, so negative 2x. Okay. Now let's go ahead and graph. Let's do the top inequality in red. We're going to graph it in red. So negative 2 is the y-intercept, so we put our first dot at negative 2. And now we're going to count out our slope. Our slope is 1/2. Okay, so that's the rise over the run. So from this dot we made, we go up 1 and over 2, and we put a new dot. We have to decide if it's a solid or dotted line that we connect them with. It's a dotted line because we're missing the or equal to part. So we connect these with a dotted line. And y is greater than, okay, the rest of the inequality. So greater than means that we shade up from our line that we just made. Now let's do the second one in green. Okay, so the y-intercept, again, that's the number that doesn't have the x next to it. So that's 3. So we find 3 on the y-axis and put a dot there. And then our slope is negative 2 over 1. Okay, so we rise negative 2, which basically means from this dot we go down 2, and then to the right 1, and we put another dot. And we're going to connect with a solid line because of that or equal to. So we connect with a solid line. Okay, and then y is less than all of this stuff. So we are going to shade down from there. And then again, we look, where does the red and green shading overlap? It overlaps right in here. Okay, and so any point that's inside this orange triangle would be a solution. And anything that's not outside, that's not inside the triangle, that's outside of the triangle, is not a solution. That's lesson 6.6. Now let's move on to lesson 6.2, solving systems through substitution. So what we're trying to do is we're trying to solve we've got two equations here. Okay, so now we're back to equations. They're not inequalities, they're equations. We want to solve one equation for a variable, and it doesn't matter if you solve it for x or for y, you just try to do the easiest thing. Okay, well the top one is already solved for x, so let's say that that one's the one that we're going to solve for x. Now we're going to take this one and we're going to plug it in down here. So they're saying x equals this. So now instead of x, we're going to fill in this. So instead of, on the bottom equation now, instead of x, we're going to fill in 2y minus 4, and then we copy down the rest of the bottom equation. So plus 8y equals 16. Let me get a better color because I can't really see this. Okay, now we're going to go ahead and solve this equation right here just the same way we're used to solving equations. So we combine the like terms. So 2y plus 8y is 10y, and then that negative 4 is still kind of hanging out. Okay, equals 16. solving for y, that negative 4 needs to move to the other side of the equal sign. So it's negative now. I move it by adding it. Okay, those cancel out. So then I get 10y equals 16 plus 4 is 20. Now I want to split up the 10 and the y. They're being multiplied, so I split them up by dividing. And I get that y equals 20 divided by 10 is 2. All right, y equals 2. So now I can take this and plug it back into either one of these equations and then solve for x. So let's plug it in here. Okay, so now we have x equals 2, and instead of y, I know that y is 2 now, so I'm going to fill in 2 minus 4. And now I'm going to find out what x is. Well, x is 2 times 2 minus 4. So 2 times 2 is 4 minus 4. Okay, well 4 minus 4 is 0. So x is 0. So my answer is 0, 2, because the first number is always the x and the second number is y. There's my answer right there. Try another one. Okay, now in this case, neither of these is solved for one of the variables. So we just look and see what's easiest. Well, this x, that's just an x, so it might be easiest to solve this bottom equation for x. Okay, well that's a negative 4y, so let's add 4y on both sides to move that 4y over. Okay, and we get x equals 11 plus 4y. All right, now we're solved for x on that bottom one, so let's use that. And now we'll take this and plug it back in to the top equation. Okay, so now the top equation says 4y minus 5 times. Now instead of x, we're going to fill in 11 plus 4y equals 9. 4y, and now we have to distribute this negative 5 through the parentheses, so negative 5 times 11 is negative 55. And negative 5 times 4y is negative 20y, and all that equals 9. All right, combine our like terms, so 4y minus 20y, that's negative 16y. We saw that minus 55 right there, equals 9. I'm getting y by itself, so that negative 55 has to move over. Add 55 on both sides. So then I get negative 16y equals 9 plus 55 is 64. Now I want to split up the negative 16 and y, so I'm going to divide by negative 16, divide by negative 16, and I get y equals 64 divided by negative 16 is negative 4. Okay, so y is negative 4. Now let's take this y is negative 4 and plug it back in somewhere. Doesn't matter where you plug it back in. Let's plug it back in to the bottom equation. So now we have x minus 4 times, and instead of y we're going to put in negative 4 equals 11. I should really do this in a different color. Okay. We'll do that in red. Okay, so then we have to solve it. So first let's do our multiplication here. So negative 4 times negative 4, that's positive 16. So x plus 16, because it's positive 16, equals 11. Solve for x, so we need to move that 16 over to the other side. So we have to minus it. X equals 11 minus 16 is negative 5. So x is negative 5. So our answer is negative 5, negative 4, because the first number is the x and the second number is the y. So there is your answer right there. Now we move to the last lesson of this chapter, lesson 6.3, solving systems by elimination. Sometimes when you get these equations, if you line up the variables, so like the x's are over each other, the y's are over each other, and the constants are over each other, and they're both in the same exact form, and the equal signs are over each other. If you line them up, you notice that they have opposite coefficients. Like this is a negative 2y and that's a positive 2y. So if you have it like this, and these are rare, but if you have it like this, negative 2 and positive 2, if you added those together, you would get 0. So let's just total this up. So it's like we're going to add everything. So x plus 5x is 6x. And negative 2y plus 2y, negative 2 plus 2 is 0. Okay, so since there's 0, we can just cancel them out. Equals negative 19 plus 1 is negative 18. All right, now solve for x. We need to split apart the x and the 6, so we're going to divide by 6 on both sides. And we get x equals negative 3. There's part of our answer. Now we take this x is negative 3 and we just plug it back into one of these. Let's plug it back into the top one. So instead of x, we're going to put negative 3 minus 2y equals negative 19. Now let's solve it for y. That negative 3 is going to have to move to the other side, so we add 3. Negative 2y equals negative 19 plus 3 is negative 16. And then we divide by negative 2, divide by negative 2, and we get y equals 8, because negative 16 divided by negative 2 is positive 8. So then our answer is going to be negative 3, 8, because the first number is x and the second number is y. So that's our answer right there. Let's try another one. This one's different because we lined up our equations, so the x's, the y's, the equal signs, and the constant numbers are all lined up with each other, one's over the other. And they're kind of close. We've got 3y and 3y. They're both positive though. And it would be very convenient if one of them could be negative. So if that happens, we just basically multiply everything by negative 1. Because what we really want to do is we want to flip the signs in this bottom equation. So negative 1 times negative 2x, well, that becomes a positive 2x. Okay, so this is like a positive 2x now. All right, and negative 1 times positive 3, negative 1 times 3, that's negative 3. So now this is becoming like a negative 3y. And then negative 1 times negative 5, that's positive 5. So this becomes positive 5. And then we do just like we did in the last problem. We tally everything up, so 3x plus 2x now is 5x. 3y minus 3y is 0y, so we cross them out. And 15 plus 5 is 20. Then we solve for x. Divide by 5, divide by 5. X equals 4. So there's part of our answer. And then we take this x equals 4 and we plug it back into one of these. So let's plug it into the top one. 3 times, and instead of x, we're going to put 4. Plus 3y equals 15. 3 times 4 is 12, plus 3y equals 15. Move that 12 over by subtracting it on both sides. So we get 3y equals 3. And we divide by 3 to finish solving for y. And y equals 1. So our answer is 4, 1. Okay, good luck. Quiz is on January 15th and 16th of 2014. Good luck on that.